Hello YouTube! Today another video in the series Zork University, where I try to make you smarter while watching Elder Scrolls lore. Last time, with the genetics video, people wanted more of smart Zork that will make you smarter, and thus I give you more. Today we will cover the Elder Scrolls laws of physics. We won't go into it too deep, because otherwise it just will get boring. But I hope that I can give you a fun, entertaining video where I talk about Elder Scrolls and meanwhile talk about physics. So, a while back I saw a video by Shoddycast, where they calculated the energy a giant would have to put into slamming his club in the ground to launch you into space. That video was very fun to watch and I can really recommend it, but one thing of that video bugged me. As their point of reference for weight and length, they use the average weight and height of a breed of horse that we ride in Skyrim. This is problematic, as this is just not that accurate, as every horse is different, and an average does not really give a good representation of anything in the game. To be honest, it's just my opinion. It was accurate enough for what they wanted to do, because you would need a lot of energy for the giant, and basically those couple of newtons that it would be off, that doesn't really matter. But it's not at all accurate enough for what I aim to do here for Zork University, my new series. So, first of all, we will need our own point of reference for weight and for one for distance. The problem is that while I wanted to do this video for a long time, we don't really have any canon things we can know the exact size of, or any confirmed units of length or weight. I looked at iron bars, buildings, at weapons, at animals, at humans, at everything. The quest for this video seemed hopeless and I was just, well, staring a bit at my Elder Scrolls merch collection, just being sad that this video could never happen. Well, I saw it. With the collector's edition of Oblivion, I got this. An official replica of a septim coin. That Bethesda calls an authentic replicated septim, the official currency of Tamriel. Here, in my hand, I have a physical object that is ripped directly from the games, recreated in an official manner by Bethesda. So, we have a point of reference. And with that in mind, let's calculate. The diameter of the official replica is 3.7 centimeters or 1.46 inches in American units. This means we now have an official canon height in one of the games. Now something for weight. Let's take a gold bar to make it easy. If we put a coin against a gold bar, we can actually calculate the volume of the gold bar. The bar is 4.26 coins long and 1.53 coins wide, and this is all calculated at the middle of the bar to make it as accurate as possible, since it has a trapezium form. The height of the bar is 0.84 coin, so if we calculate that back to normal units, the bar would be 15.76 centimeters long or 5.92 inches. It is 5.49 centimeters wide or 2.16 inches wide and 4.4 centimeters high, and that is 1.72 inches. If we multiply those numbers to calculate the volume, we would get a volume of 380.7 cubic centimeters or 149.88 cubic inches. We now have something we can work with, as we know the density for gold. The density is a set weight for a material per unit of volume. So in this case, we look at the gold density, so the gold weight per cubic centimeters. Sorry Americans, I'm European. I'll explain it. Gold density clocks in at 19.29 grams per cubic centimeter. So if we multiply that, we now know that our gold bar we have here is officially 7,309.4 grams or 7.3 kilos, or for the Americans 16.9 pounds. Nice, we have that now. But for my calculation to work, we here at Zork University need a more convenient unit of distance. While our coin here is a nice distance of 3.7 centimeters, it's a bit small for bigger calculations in the world. So I decided to go for a second official unit of distance here at Zork University. Our second official unit of distance is Farengar. One Farengar is 36.2 coins in length and is thus 1.3 34 meters or 4.3639 feet. Remember, you cannot pass Zork University if you don't know our signature units of distance. So, let's see how far we can get with physics. Let's calculate the gravity acceleration on planet Nern. Let me explain what that is. Gravity acceleration is something we have on every planet. When you drop something on Earth, it falls down because of gravity. The acceleration an object has while falling is the gravity acceleration. This acceleration is caused by gravity. Each planet and each object in the universe has its own gravity acceleration value, so there is gravity in the Elder Scrolls games. The planet Nern also has to have its own gravity acceleration if there's gravity. The standard for Earth's gravity acceleration is 9.81 meters per second squared. So what's the gravity acceleration of Nern? For that we need a formula, and don't worry, it's not that hard and I'll explain it. We need an action, a measured fall of an object on Nern, and a formula to bring our measurements to an answer. We will use this formula. St equals S0 plus V0 times the time, t, plus half times a multiplied by t squared. In this formula, St is the distance that the falling object has passed in the action you want to measure for the acceleration. S0 is the starting distance. V0 is the starting speed. T is the time passed during the action, and A is the acceleration, and we want to know that one, as in this formula and in this particular scenario, this acceleration is the gravity acceleration. Because you can use this formula for a lot of things, like the movement of a car, or whatever you want to use it for that has acceleration, you can use this formula. But in this case, in the case of a falling object, the acceleration is caused by gravity, so the acceleration in the formula is the gravity acceleration. Alright, so for this experiment we use this action. So if we analyze this part, we can see that from the start of the fall until the landing, it is exactly 1.04 seconds. So we have the time it takes to fall and the time of the action. Before the start of our experiment, the gold bar does not have any speed, it's just there static in the air. So V0 is 0. St is 3 Farengars, so the distance traveled is 3 Farengars from the top to the bottom. So 4.02 meters it will fall down, the gold bar. S0 is also 0. And we want to know A, the acceleration. Because V0 and S0 are both 0, the formula becomes a lot more simple. Now the formula we will use is St equals a half times A multiplied by t squared. Now let's remodel this formula a bit to this. Acceleration equals 2 times the distance traveled divided by time squared. So if we enter our values, we get A equals 2 times 4.0 divided by 1.04 squared, for which the answer is 7.43343 meters per second squared. So the gravity acceleration on Nern is actually 7.43 meters per second squared. That's a bit less on Earth, and that actually makes sense. And when we are jumping in Skyrim, your time in the air is actually a lot longer than it would be on Earth. I mean, just jump in the air right now where you are, and then do it in Skyrim, and you will see that in Skyrim you're in the air a lot longer, and your time to fall down is a lot longer than you'll actually see here on Earth. That makes sense, because the gravity acceleration is a lot less. So to put this in perspective, our Earth gravity acceleration is 9.81 meters per second squared. That's called 1 g. If we do the math, then Nern has a little under 0.76 g's. So, that was actually the second Zork University video, and I know it's quite basic. A lot of you will probably say, you did all this math, and what you gonna do now when you have the gravity acceleration? Well, this was already very hard. I'm sorry, it was hard. Probably in the next video on this, we're going to do something else where I try to make you smarter while talking about Elder Scrolls lore. I really like this format in which I just do something from real world knowledge and then apply it to Elder Scrolls. I already did this in the genetics video, and I can really recommend the genetics video as it gives a lot of insight. And just remember that what we did here will probably be the basics of every future physics video. And don't worry, there will be a lot of regular lore videos. This series that I decided to call Zork University is just, well, like a side series that I can do from time to time when I really want to do something more academic than just tell the story. But I really enjoyed making this one. If you have any other requests for more scientific videos or for regular videos, please put them in the comments, as I really enjoy making videos. I also want to thank my friends Arthur, Julian and Danique for helping me with this video. And also a special thanks to Jeroen for checking out the script. And well, if you want to support me on Patreon, that's also possible. If you like this video, give it a like, subscribe, do all those things of course. If you want personal contact with me, there is my Instagram and Discord in the description. As I mentioned before, you can support me on Patreon and you get your name at the end of every video, and you get, of course, access to my exclusive soundtrack, which is totally worth it, I've heard. But stop with the shameless self-promotion. I will see you all in the next video. Bye bye. I really hope you enjoyed this one.